I'm Anil Kumar. In this video, we'll discuss how to sketch graph of a rational function. We have taken f of x equals to x squared minus 3 over x cubed as our function. First, I'll describe the characteristics of this function, and then we'll find interval of increase or decrease. We'll find local extrema using first derivative. Analyzing second derivative, we can find the interval of concavity and point of inflection. Once we have all this information, we'll sketch the curve for the given function. So let's look into the characteristics of the function. Some of the important characteristics whenever you look into a rational function are asymptotes. Right, so let me write down here asymptotes. Since degree of denominator is higher than that of numerator, we have a horizontal asymptote here, right? So that is very clear. So we have a horizontal asymptote which is y equals to 0, right? So when x approaches a very large negative or positive infinity, the function is going to approach 0. So that becomes your horizontal asymptote. Now, you will also observe that when x approaches negative infinity, in that case, numerator is positive, however, denominator is negative. We see that the y value approaches 0 from the negative side. And when x approaches positive infinity, y approaches 0, but from the positive side. Now, that is a very important information which helps to sketch the graph of the given function, right? So let me try to show it on the graph how it should look like, right? It's important to understand this. So let us say that is x and y coordinates. What we are saying is that the graph of the function approaches like this on the left side and like this on the right side. So that is horizontal asymptote. Now let's look into vertical asymptote. For vertical asymptote at x equals to 0, we know we do have a vertical asymptote. Now, if I have a negative value, right, approaching 0, in that case, numerator is negative, denominator is negative. So if x approaches 0 from the negative side, y does approach infinity. However, both are negative, so it will approach infinity towards the positive side. When x approaches 0 from the positive side, in that case, we have a small number here, right? So that gives you negative answer. So y approaches negative infinity. Now this is a very important information which we gather from the type of function which is rational. Now what else you can figure out from this? Well, we can always find the x and y intercepts, for example, correct? So let's figure out all other things which are important for us to consider, which will also help us to sketch the graph. So one of them, as we say, x and y intercepts. Now, when will the function have x-intercept? So x-intercept is, let's write down, x-intercept. For x-intercept, y equals to 0. That means x squared minus 3 is equals to 0, or x is equals to plus minus square root of 3. So those are the values for x-intercept. So let's say these are the values for x-intercept. Okay, so this is minus square root 3 and that is plus square root 3. We also know we have a vertical asymptote at x equals to 0. So that is the vertical asymptote which we have already mentioned, right? So vertical asymptote is x equals to 0. And we also know that when you approach from the negative side, the function approaches positive infinity, kind of like this, and here it is negative infinity. So all that information we have already got. Now, there is something about symmetry. So let's check symmetry of the function. So if I substitute minus x, f of minus x, I do get minus x whole square minus 3 over minus x whole cube. Now this is equal to x square minus 3, but the denominator returns with a negative value, so we get minus of f of x. Now that means we are working with an odd symmetry function. So that means we have odd symmetry. Now odd symmetry means the function is symmetric about origin, right? That means symmetric about origin. So what all we have seen, it matches with the information which we have got so far. Now, to find the interval of increasing and decreasing and to find local maximum and minimum, we should actually find the first and second derivative of the function, analyze those derivatives, and then sketch the function. So now let us find first and second derivative for the function. So we are given f of x as x square minus 3 divided by x cube. Let us find the first derivative of this function. We'll apply the quotient rule to find the derivative. So we get x to the power of 6. 2x is the derivative of the numerator times x cube minus, we have x square minus 3 times derivative of x cube, which is 3x square. Now let's try to simplify this. We have 2x to the power of 4 minus, when you multiply this, we get 3x to the power of 4 minus, and minus becomes positive. 3 times 3 is 9x square divided by x to the power of 6. Now 2x to the power of 4 minus 3x4 is minus x to the power of 4 plus 9x square divided by x to the power of 6. We can take x square common. So if I take x square common, well, we can also take, okay, let's keep x square common here. Now in that case, let me write this term first. We get 9 minus x square. Is it okay? So we just interchanged commutative property. X to the power of 6. And now x to the power of 6 and x square, you could simplify a bit. We get 9 minus x squared over x to the power of 6. 9 minus x could be written as 9 minus, okay, let's write 9 minus x squared over x to the power of 4. So that is the derivative. Now for critical number, derivative should be 0 or undefined, right? So we know that for critical number, the first derivative is either 0 or it does not exist. So therefore, we actually get, in this particular case, 2 values from the numerator, which gives us 0, and then 1 from the denominator, which gives us undefined value. Correct? So we can analyze this particular derivative right here on the side. So let's analyze this. I'm trying to squeeze in all the information in this page. So let's analyze it right here. So let me draw a line here. Try to analyze the first derivative. Now what we see that we have zeros at plus minus 3, right? So plus minus 3 are the zeros. Let's say this is minus 3 and this is plus 3. And we do have a vertical asymptote at 0. So let me make a circle here saying that in this, x is not equal to 0 in the domain. Is that clear? Now, denominator is always positive, correct? Denominator is always positive. However, as far as the numerator is concerned, we are talking about the analysis of first derivative. We are trying to analyze the first derivative here. Now, if I take a test value which is close to 0, in that case, we do get a positive value. Is that clear? So we get positive value for any value of x which is in the interval -3 to 0. If I take a value of x greater than 3, so minus x square will be more negative and we get a negative result. So in this side we'll get negative result. So from here we can decide about the interval of increasing and decreasing, right? So as you can see from here that from minus infinity to -3, first derivative is negative, so the function will be decreasing, correct? From -3 to 0, the function will be increasing. From 0 to 3, since first derivative is positive, it will also be increasing. But after 3, we have negative first derivative, so it will be decreasing. Now that clearly indicates that we do have a minimum value at -3 and a maximum value at +3. Correct? So let's note this down. So we have from here analysis, we have maximum value at x equals to +3, that is the maximum value, and we have a minimum value at x equals to -3. Is that clear to you? Perfect. So we got maximum and minimum. Interval of increasing and decreasing is also very clear here. So let me summarize this information. So what I will do here is we'll also find the value of the function at these 3 points, which are -3. So if I substitute -3 here, what do I get? -3 will give me 9. Let's calculate. So -3 square is 9, right? So we get 9 minus 3 in the numerator divided by -3 cube. So it's a negative number, right? Divided by 27, we can say. So 6 divided by 27. So we get, it's better to write in fractions. So let me do it without calculator. So if I substitute -3 here, then I get -3 square -3 over -3 cube. Now, so that means we get a value which is 9 minus 3 over -27, or -6 over 27, and that is equal to, dividing by 3, we get -2 over 9. Perfect. Now let's calculate the value for 3. Now if I write 3 here, this is again 9 minus 3, but this value is positive, right? So that will be positive 2 over 9. We can also derive the result from odd symmetry. So now we know that we have a maximum at 3 2 over 9 and minimum at x equals to -3 minus 2 over 9. Is that clear? Let us write the interval for increasing and decreasing. So interval for increasing is where? Interval for increasing is when the first derivative is greater than 0. Now we can see from here that first derivative is positive from -3 to 0 and also from 0 to +3. So that is the interval of increasing. How about interval of decreasing? So let's write down. Interval for decreasing is when the first derivative is less than 0. It is less than 0 from -infinity to -3 union from 3 to infinity. 3 to infinity. So that is all the information which you can easily get from the first derivative, right? Okay. So let me write down here. We go increasing, decreasing, and now let me also mention maximum value is at +2 over 5 at 3, right? So 3 2 over 9, and minimum is at -3 minus 2 over 9. Correct. So these are the values which we got from the first derivative. Now, let us analyze the second derivative. So for second derivative, I'm going to utilize this particular formula, which is f dash x is equal to this one, 9 minus x squared over x to the power of 4. So let's take it to the next page and find the second derivative. So we have calculated that the first derivative for this particular function is 9 minus x squared divided by x to the power of 4, right? So that is the first derivative. From here we can calculate the second derivative. Again, apply the quotient rule to find the second derivative. We get x to the power of 8, derivative is minus 2x times x to the power of 4 minus derivative of denominator is 4x cubed times 9 minus x squared. Now let's simplify the numerator. We get x to the power of 8 minus 2 x to the power of 5. Now let's open this. We have minus 36 x cubed and plus 4 x to the power of 5. Now x to the power of 5 and x to the power of 5 can be combined. So we get 2x to the power of 5 minus 36x cubed over x to the power of 8. We can again factor out 2x cubed and we get x squared minus 18 and the denominator is x to the power of 8. Now that can be simplified by cancelling x cubed with the power. We get x to the power of 5 and therefore the second derivative could be written as, let me write down here, second derivative can be written as equal to 2 times x squared minus 18 over x to the power of 5. Okay? So that is the second derivative for us. Now, in this particular case, we have the critical numbers at, let's write down, at what? The critical numbers are at x equals to square root of 18 plus and minus, right? So we get square root of plus minus square root of 18, which is equal to plus minus 9 times 2, right? Which is 3 square root 2. Perfect. And also at x equals to 0, since it does not exist at x equals to 0. Now let's try to analyze the second derivative. So we'll analyze the second derivative and then see where is it positive and where it is negative. So we are trying to analyze the second derivative here. We have 3 critical numbers to work with. One of them is 0. The other 2 are plus minus 3 square root 2. So we have minus 3 square root 2, 0 and plus 3 square root 2. These are the functions. So if I take a value which is, now denominator on the negative side will be negative, correct? So if I take a value which is greater than minus 3 square root 2, that means that this will be positive. On the left side, let's take left side here. So if I take a value here, let's say minus 10 for example. So if I take minus 10, the numerator is going to be positive, right? 100 minus 18. However, denominator will be negative. So we get negative here in this interval. So let me write down negative here. If I take a value minus 1, in that case, both numerator and denominator will be negative, resulting into positive value. A value which is kind of 1 will make numerator negative and denominator positive, right? So what we get here is negative. And then if you take a value plus 10, in that case, both are positive, so you get positive. And that clearly shows that the concavity is negative, means concave down. Then we have concave up, concave down, and concave up. Now that gives you 2 point of inflections, right? And also concavity, this is positive and this is positive. Is it okay? And these concavities are negative. So we can summarize. And these are our point of inflection. So we have, actually speaking, 3 points of inflection where the concavity changes. So these are all point of inflection. So we have 3 points of inflection. We can always find these values, correct? So these point of inflections are at minus 3 square root 2 plus and minus. Perfect. So we can find these values. Now the question is to graph the function. So what I will do here is kind of squeeze in the graph right in this particular space without moving to the next page. So what we also gathered here, let's find point of inflection. So we'll do the value of the function at minus square root 3 and plus square root 3. So f of square root, 3 square root 2. 3 square root 2 is how much? So if I write 3 square root 2 and square it, which is, let me write down. We have 3 square root 2 whole square minus 3 over 3 square root 2 whole cube. So that gives you 3 square is 9. 9 times 2 is 18. So we get 18 minus 3 over. Here we get 3 cube is 27 times, let's calculate. So what we get here is actually 18 minus 3, we do 18 minus 3 equals 2. And we are going to divide this by, within bracket, 3 square root 2 bracket cube equals 2. So we get this value. Let me write down the value as 1.767. Is it okay? So that is the value which we get for 3 square root 2. Now we could actually also find the value for minus of this function. So f of minus 3 square root 2 will give us negative of this. So let me just write negative 1.767 because of the order geometry, right? This value is negative here. Okay. Now, based on this, let us sketch the graph of the function. Okay. So what we all information which we found so far is kind of like this. Let me draw x and y axis here. Okay. So in the first page, we calculated the value for maximum and minimum, and we also found that so the behavior of the asymptotes, right? So let me club all the information here. What we get here is a vertical asymptote at x equals to 0. We are trying to graph the function now with all the information collected. Is it okay? We have now discovered, so we have x-intercepts at plus minus square root 3. So we have x-intercepts at plus minus square root 3. We have the behavior of the curve, which is like this. It is approaching 0 in this fashion, right? So it approaches from above and below, as we saw in the last part. So if we connect this point, it is kind of like this. Do you see that? And it goes through this. That is how we get the graph. The points which we calculated are, so the point of inflection are these points, where the concavity, it goes up and then down. So these are the point of inflections where the x value is minus 3 square root 2 and that is plus 3 square root 2. The intercepts which we have are at square root 3 and plus and minus square root 3. So this is square root 3 minus, this is square root 3 plus. The maximum and minimum values were found at the value of square root 3 minus. So the maximum value which we calculated was at 2 over 9. So just a minute. Let me push this a bit. So the maximum value here was calculated at 3 and the y value of this was 2 over 9. The minimum value was calculated as minus 2 over 9 at minus 3. Right? So bringing all the information together, you can clearly see that that is how the graph of the given function will look like. And it has odd symmetry, right? Let me write down. So we have odd symmetry with the maximum minimum values as shown here. So you'll see that the function approaches 0, but from below on the left side and from the top from the right side. So I hope with this you clearly understand how to sketch graph of a rational function. So we need to calculate the asymptotes, horizontal and vertical asymptotes. We can find x and y intercepts. Here, since we have a vertical asymptote as y-axis, we do not have any y-intercept. And then we could find increasing and decreasing intervals using the first derivative, maximum minimum using the first derivative, point of inflection and concavity we calculated using the second derivative. So I hope all the concepts are absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe my video, that would be great. Thanks for watching and all the best.